determine the 10th term of this sequence. Okay, so it looks like it's been increased by 7 and then by 18, right? And then by 44. So that there doesn't seem to be too much of a pattern there. Let's look at the common ratio. 10 over 3 is the first common ratio. What's 28 over 10? If you reduce that, you get 14 over 5. Okay, what about 72 over 28? If you reduce that, you get 18 over 7. Okay. And the next one, 176 over 72. So that's 44. 18. Divide top and bottom by 2, you get 22 over 9, right? Okay, so I think that there's a pattern here. Right, it's increasing by 2, right? Increasing by 2. And up here it's increasing by 4. Okay. But the common ratio is changing. Okay, the common ratio is changing. Okay, so let's actually write this as our common ratio. So the first common ratio is 10 over 3. Second is 14 over 5. Third is 18 over 7. And last is 22 over 9. So T2, okay, so of course T1, let's write T1 is equal to 3. T2 is equal to 3 times by 10 over 3. Okay. T3, okay, so this is equal to 10, right? I'm going to write T3, the 28, as this, right, times by the next common ratio, 14. It's not actually, I shouldn't call it common ratio, the next ratio, right? So 14 over 5. Right, T4 will be all of that by the next one, which is 18 over 7, and so on, right? So T5 be all of this, all of that, 22 over 9. So you can see that the recursive formula is not going to be that hard to write. Okay. So the numerator is increasing by 4. The denominator is increasing by 2 by starting to happen in the second term, right? Okay, so we're starting the first term is 10, 14, 18, and so on the numerator. So if we set a equal to 10 and the common difference to be 4, you get the general term for tn for the numerator is 10, n minus 1, 4. That's 4n minus 4 plus 10. That's 4n plus 6. But this starts to happen starting the second term. So we actually have to adjust and make n minus 1. So you get 4n minus 4 plus 6 is plus 2. So for example, if n is 2, do you see that you get exactly 10? When n is 3, we get exactly 14. Okay, so we have Tn is equal to Tn minus 1 times by the numerator will be 4n plus 2. Okay, and similarly for the bottom, the pattern is 3, 5, 7, 9. Okay, so the general term for the bottom, so let's call it Tsn maybe, let's call it Un. I don't want to call it the same Tn. Un, it's going to be, typically it's 2n plus 1. Right? When it's 1, it's 3. When it's 2, it's 5. But we want to apply that. We want to match it with this number here. So when it's 2, I want it to be 3. So when it's 2, right now it's 5. So we can adjust this by replacing n with n minus 1. Okay, now if it's 2, it's 3. If it's 3, it's 5, and so on, right? So at the bottom is 2n minus 1. So this is the recursive formula for it. So T1 is, of course, is equal to 3. So how do we get the general term? For the general term, let's go back here. Let's reduce this for t2, and we get 10. Note that that reduces 2. You get 2 times by 14. Reduces gives you 2, so that's 2 squared times by 18. Similarly, right, this will cancel out with this to get 2 cubed times by 22. So there's a numerical pattern forming. Tn. Initially it's 3, okay. So 3, and then it's 10, okay. And then note that just this number at the end here is just increasing by, okay, it's increasing by 4, right? Increasing by 4. And the power of 2 is just increasing by 1, okay. 1, 2, 3. So how can we make 3 to 10 consistent? Okay, let's see if we can do that. If you subtract by 4 from 10, you get 6. Okay, so maybe this is, we can think of it as half times by 6. This is going to work out. This is 2 to the power of negative 1. We can write 2 to the power of 0 here. So now look at the power. Negative 1, 0, 1, 2, 3. Okay. So when t is equal to 1, we want it to be negative 1. So let's subtract 2. Okay. 6, 10, 14. This is an arithmetic sequence. So Tn is going to be 6 plus, the common difference is 4. So 4n minus 4 plus 6 gives you 2. Okay, so it's going to be 4n plus 2, right? So if n is equal to 1, we get 2 to the power of negative 1 times by 6. When n is equal to 2, we get 2 to the power of 1 times by 10. It gives you exactly what we have here. So that's the general term.